today I am really honored of hosting Mr. Luca Deri, the founder and the inventor of DPI inspection, and Raffaele Borgese. Raffaele Borgese is an entrepreneur, and he is using both DPI and Flashstart. And his judgment, his review will be very important today to understand and to learn how the two solutions can work together. But let me just share a very quick presentation. Okay, can you see the presentation now?
Yeah.
Great. So let me introduce the three speakers of today: Luca Deri, founder of Ntop; Raffaele Borgese, CEO of IES in Italy; and me in the final section. Today we will talk around the combination of both Ntop and Flashstart. It's important to understand and to learn the potential, the power, and the capabilities of combining both deep inspection, which is the ability of examining data packets as they travel across network, and Flashstart. Flashstart is, we can say, the #1 leading DNS service, the fastest in the world, according to the independent chart, dnsperf.com, and we can filter against malware and bad content. Today, let's start from the deep packet inspection, and Flashstart will come back later. So right now, I am proud of introducing Luca and Raffaele in this section. Let me remind that everything will be recorded. It will also receive a video recording at the end of the event, and the ability of accessing the trial and request some more information for both deep inspection, DPI, and Flashstart. Luca, Raffaele, please go ahead at your earliest convenience.
Mr. Deri had the precedence.
Okay, so let me start with my presentation. Okay, good morning, everyone. Today I'm going to talk about deep packet inspection. And this is a technology that allows you to go deep into the packet, as the word says, and that allows you to understand what is happening in a network traffic environment, even though modern traffic is likely to be encrypted. So I'll go through this technology. I'll give you some potential ideas and potential integrations with existing protection methods such as Flashstart. So what is DPI? So as the word says, we are talking about packets. Okay, so we need packets. And when you have a network traffic monitoring system, the challenges are basically twofold. One is the speed. Sometimes the link is very high speed, so this demands a solution that is fast and reliable because we need to keep up with the traffic. And the second problem is that we need to see all the packets. We cannot see a part of the packet. In general, modern traffic is encrypted. So there is a word called ETA, encrypted traffic analysis. That means that we cannot simply say, okay, we are going to limit ourselves to unencrypted traffic, but we have to also monitor encrypted traffic. When I say encrypted, it means that the content is obfuscated, so there is no way for you to understand what is passing on a network. There are various encryption methods. Okay, some of them are standard, such as TLS, that is the typical encryption method that many websites are using, or QUIC, that is the successor. But in general, there are many protocols. Probably there are more relevant protocols that don't use those type of encryptions. A typical example is a VPN. Okay, so there are many different VPN types, and in particular mobiles. And due to security concern and privacy concerns, those protocols are not based on any standard. So they try to be hidden. Okay, they try themselves to be perceived as a different type of protocol. But then at the end of the story, so they are simply variation of existing ones. So when I mean ETA, I mean also the ability of understanding and detecting those type of protocols. NDPI is an open source library that we are developing since 13 years at Ntop that is the cornerstone of our application. So the packet inspection requires analysis of packets. Typically, I will go through this later in this presentation, requires to monitor the first few packets of a communication, not everything, because at the beginning of a communication, basically the two peers are exporting and exchanging, secrets, or are exchanging, the data that they want to talk about later in the communication. And the library that NDPI represents is rich. We have over 450 protocols. We include the main ones, okay, those that are the most popular ones are included. So for instance, video conferencing, gaming, simple TLS protocols and so on. In addition to that, we're also able to report some security indicators, something we call flow risks. Basically, we report not just the application protocol, let's say TLS or Zoom or something like this, but we also report if there are some risks that come along with that communication. A typical example, a very simple example, is on TLS when you are talking with a peer whose certificate does not match the expected ones, or when you are talking with a peer that has a certificate that is expired, or when you have clear text traffic such as HTTP, so you have traffic that contains some potential malware such as SQL injection or remote code execution, suspicious DJ, so namely domain names and host names that are very funny, okay, they are very long, that are usually not to be generated by a human, okay, system, such as a website, but they're probably programmatically generated that usually requires some more attention. The library is GPL. It's available on GitHub. The link is at the bottom of the screen. The idea here today is to understand what type of feature this library features and what you can do with it, not just talk about the library. Every protocol in NDPI is identified by two words, the major and the minor protocol. The major protocol is the transport protocol. In this case, for instance, DNS, Facebook, means that somebody is going to Facebook. So it's as requested, something like www.facebook.com as a DNS protocol, or quick YouTube upload means that somebody is uploading a video on YouTube using quick as a transport. Often the transport part is not very relevant because people care about the application protocol. So people talk about, let's say, YouTube upload, but they don't care if it's over quick or TLS. The important thing is the application. When I say application, I don't mean a standard application that is described on an RFC, on a standard document. But application means that a certain app, for instance, YouTube, is using a certain protocol to carry its own job. So regardless of the fact if the protocol is registered or not, so we identify that as a protocol. Okay. So a typical question is, how many protocols do you support? Okay, while we believe that this is not the right question, because when you have about 500 protocols, basically we cover most of the internet. The question is if you can extend the library, and the answer is yes, because in many countries, particular where probably you're here today, you have different or national protocols. Probably you have some streaming protocols that for local television. So it's please.
Sorry. Can you share again the slides, because I can see the slide presentation below in the screen. Okay, that works. Okay.
So probably
that's fine.
I should remove the sharing.
The screen share.
Yeah.
It's okay. Thanks.
Nice movie. No, sorry, it was close. So the protocol dissection works basically as follows. So because there is not a rule for DPI, because people try to obfuscate the traffic by sending traffic on non-standard ports or trying to hide protections. Basically, what happens with DPI is that we try to dissect every single protocol starting from the port that is more likely to be used. And then at every single packet, we apply all the potential dissectors. So let's say if you see TCP port 80, that is the HTTP port, we start first with HTTP, and if that one does not match, we try to a different dissector. And in case, so we have tried too many times, so in case there are no dissector matching the traffic, we simply say unknown. Otherwise, we report the application protocol. The application protocol is the most important thing, but it's not the only one. So for instance, another important information that many people require is the category. A category is a way to, let's say, identify the traffic and classify into groups that are easier to understand. So for instance, if you want to say peer-to-peer, I want to block all the peer-to-peer traffic, right? So instead of going through a long list of protocols that probably we, the authors, we don't even remember, so we simply say, I want to block a category. So let's say I want to block peer-to-peer, or I want to block file sharing, or I want to block screen sharing. Okay, these are type of things. And it's easy. At the moment, we have 120 categories. So this simplifies the configuration because people can really decide to work in macro categories, simply as a flash start. So you can block a specific domain or a specific application, or otherwise you can say, okay, this group of applications, let's say social networks, are relevant. So it's the same concept. And as we add new protocols, the category is automatically updated. So it's an easier way of doing that. In addition to that, there is another perspective, okay, called protocol breed. When we have a breed, so we don't talk about the type of protocol, but we talk about the fact if the protocol is a problem or not per se. Let's make an example. So if you have an application such as Netflix, so this is something we call fun. So it's something that you do it for pleasure, right? So it's something that you don't expect to see on a business environment. Instead, if you see Tor, the onion ring, this is a potentially dangerous protocol because it's a protocol that allows you to overcome security limitations of a network. So therefore, that it should bring some sort of more attention to the network administrator, or that you should block it. So these are the type of things. So breed and categories are two different aspects of the same protocol. And depending on what you're doing, so let's say if I'm in a business environment, I want to block all the protocols that are not supposed to go there, okay? So you can block, the breed fun, okay? Otherwise, if you have a category, you can block other type of breed. When I say block, it does not necessarily mean, don't pass this traffic, but you can say also something different, such as, shape the traffic, so reduce the bandwidth of a certain traffic, or apply other type of policies, such as, put this traffic on a different VLAN, things like that. When we combine NDPI with cybersecurity, you can create a powerful system that allows you to, let's say, to stop specific threats, okay, at the network level, simply at the beginning of the communication. Because as I've said, DPI is at the beginning of certain communication when you have an initial communication. For this reason, we have implemented inside NDPI something called flow risk. That is the ability of detecting situations where the traffic does not respect what we would expect. Okay, so for instance, you have a clear text traffic that is carrying on a binary traffic, so therefore something that should not be carried on an insecure protocol. Or for instance, you have a certificate that is malicious, these type of things. So we have put a different color depending on the type of traffic. The red one means only encrypted traffic, blue both encrypted plain traffic, and black only clear text traffic. As you can see, so with this library, it's possible to analyze everything, including encrypted traffic. That is the main thing. Now, when you want to see NDPI in passive traffic analysis, so in essence, it's possible to identify the traffic to see what is happening. I will show later a quick demo, and then to apply, the rules based on what it has been detected by the library. But in essence, it's a live exercise. And in addition to that, we have something called fingerprinting. So fingerprinting is the ability of labeling traffic with some rules, okay, that can be useful for detecting specific type of protocols. Fingerprints are at various levels, can be at application level or can be at the network stack level. And the network stack level, so the one called TCP fingerprints, allows us to identify the operating system. So simply looking at the traffic, that is very useful for detecting things such as, this traffic is originated by an iPad, okay, or this traffic is originated by a macOS system on ARM or macOS on Intel. So if you want to say, I want to block traffic of Intel-based Macs simply because they're outdated and they should not go on the internet, that's a possibility. Or if you want to have combinations such as, when you have Windows and you see an Apple protocol, it doesn't work, or you have an Android and you see an iPhone protocol, possibly this doesn't work. There is something unexpected. Otherwise, we have fingerprinting at application level. And there are various websites that daily publish a list of fingerprints of applications, application protocols that are not expected to be observed on a network because they are used by malware. So this is another way of using that. In addition to that, a simple way of using fingerprinting is, for instance, to anticipate problems using them. So in this example, so this is the first bucket of communications based on SIM. There are two different scanners. One is called MASCAN, the other one is ZMAP, that are very actively used by scanners to break into the system, to first do the scanner reconnaissance and then to go in, that can be easily detected by NDPI. So therefore, you can block a threat really at the first bucket and block it. If you want to do that, so in addition to the library, so we have created some applications on top of it. And one application allows you to identify the traffic and block it, in particular for things that are not easily to be blocked with a DNS, such as Flashstart does. So for instance, a VPN, okay, is a typical example, or the onion ring, or typical protocols that try to hide themselves into another existing protocol. And for simple things such as blocking advertisement, Flashstart is just a great solution. So the idea here is to say that there are two technologies, that one that offer a different level of protection, and the main difference here is that you can combine them, okay, and you can somehow create a better system simply, introducing these two different type of classification and merging them into a single system. A typical use case. So just to give some example and to be practical, I listed here some examples. So for instance, block TikTok on iPad because you don't want to do that. Okay, this is a typical need. I don't know, but it's possible. Block application protocol. I don't want to see BitTorrent or Tor on my network because my network is production network and those protocols are not likely to be seen there because probably it's the data center. Okay, or you want to block specific application features. So let's say I want to use Microsoft Teams, okay, but because Microsoft uses a lot of bandwidth, so if there is a video on, such as now, I want to allow Teams, but I want to disable video. So in case people enable video, I don't want the video to be shared on the internet. So this is another example. Another example is to block specific protocol features, such as the old insecure TLS protocol. So they should not go on my network because my network is relevant. Another type of blocks is block specific VPNs. Okay, when I say VPN, I don't mean just the standard business VPN such as Cisco VPN, but I mean other type of VPNs, probably even those that are present inside the browser, such as the Opera VPN, or those type of VPNs that allow you to overcome the typical restriction that you set on a network. Another thing is that on DNS, I want to allow only DNS, okay, but I want to disable DNS over HTTPS or the DNS over TLS. Okay, so I want to be able to inspect everything. Another possibility is to block insecure connections. So, for instance, a TLS connection with self-signed certificates or suspicious user agent. For doing that, so we have various components. We have developed a few components, so we have various options. So, from fully fledged application to simple application or simple modules. So just to keep things simple, I want to talk about this simple tool. So in this tool, so in essence, we sit on top of the Linux kernel, okay, and we configure the system in a way so that packets are sent to the application. Inside the application, you specify the policy. You can specify in a simple configuration file, say I want to see this protocol, but I don't want to see the other protocol. And this is a typical system that you can see on Linux that you can run, for example, on a gateway. Okay, you can combine with the existing Linux firewall. So this is a simple way of enforcing traffic. Before concluding this presentation, I want to show you something else. I want to show you a quick demo. So just to give you an idea of what is happening. This is going to be a passive demo, but the active demo, the inline demo will be more or less the same. So here you can see in real time what is happening. So this is the traffic that is passing on my network. Okay. So this is our video communication. So the first two links. Okay. So you can click here and you can sort them as as a simple Excel spreadsheet. And for every communication, you can go deep. You can see what is happening. Okay, so for instance, let's take this one. So you can see the communication has some retransmission. So it's not very nice to see this flow. And you can see here that it's possible to identify also the content of not just of the communication, but you see the meeting. Okay, so in this case, this is the meeting so we are doing, and these are various methods for detecting specific data about this meeting. So what is happening is the following: once we have detected this information, then we can decide that what we do is to enforce it, or we can prioritize. Okay, and in order to do that, you can specify this on a dashboard. You can specify also the application protocol that you want to force or analyze. And as I've said, it's possible to combine this with DNS-based blocking offered by FlashStat. So in essence, it's possible to combine the two words. Okay, the main difference here is the following: that while with DNS, you can specify a new DNS server and you're good. In case of TLS, or in case of this type of DPI traffic analysis, the traffic must pass through a device. So it has to go through the gateway. So therefore, it is necessary for you to enforce DPI on a device that is able to observe all the traffic. So this is the main difference. I don't want to go too deep. I want to let the other speaker, have their time for presentation, but I will be happy to answer your questions if you have some at the end of this presentation of Raffaele. Thank you. Thank you, Francesco.
Okay, so thank you so much, Luca. It has really been interesting, and we'll come back later with the question. Okay, let me just take back my slides, just one sec, because I'm a little bit slow to share again the slides. Just one sec. I'm gonna retrieve the slides. Laura, can you share the slide for me, because I can find the slide right now. Okay, here we are. Okay, so now just after talking about the packet inspection, let's mention the other actor, the other part of the defense, the DNS protocol. So DNS protocol is the oldest protocol in the net, and it was born in late 1983, when internet wasn't a reality, but it was just a sort of a connection between militaries and universities in the United States of America. When we work with a protocol, let's introduce the concept of protective DNS. So every one of us, I believe, knows very well what DNS is, and whenever we add some capabilities of blocking and releasing particular host name, we can decide whether or not blocking specific contents. The DNS protocol can really become a DNS firewall, so a real defense tool in order to protect in advance DNS resolution against potential compromised domains and dangerous content. DNS is one of the actor in the field of defense: DNS protection, firewall, IPS, EDS, antivirus, DPI. So together we can empower and we can increase the level of security. Just a little bit of history around DNS protocols. DNS protocol was born using the 53 UDP port. It's the traditional DNS, and right now it is still the widest protocol used in the modern internet. But new DNS protocols such as DOH, DNS over HTTPS, and DOT, DNS over TLS, are present online, and we are quickly introduce the new DOQ, DNS over quick, which is an empowerment of the previous DOH. It's faster and how can I say, SSL encryption is faster than ever. DNS also provide important statistics, trends, and indicator. If we have a look at our 2025 threat reports, we can extract very important data using DNS. Sorry for the Italian translation right here. I believe something missed, but no problem. The most blocked category in 2024, the 2025 reports obviously relies on previous year data, shows that pornography, weapons, gambling, drugs, conspiracy, and discrimination are the most important block category. And regarding the malware actions, the most important blocked vector has been adware, phishing, botnet, Trojan, crypto mining, and so on. If you go to flashstart.com website, you can download the official threat reports with I believe interesting trends, data, and protecting scenario. Now DNS, let me just talk and discuss our global journey began. Flashstart was born as a simple MSP and networking consultant over 10 years ago, and we have been installing network server firewalls, and we have been using the most important DNS platform, such as the historical OpenDNS. I believe it has been the very first and the most important milestone to introduce the DNS firewall concept. From our point of view, something was missing, and we wanted a global platform with very high-level technology, but with an Italian inspiration. So, with a very simplicity on board, and that's why we decided to concentrate and to move an investment over Flashstart. So building a secure DNS with quality and simplicity. Italian style, I believe Italian people have a very interesting sense of dashboard UX, but with a global outlook. The first 3 nodes was in Italy, and Milan, Rome, and Bologna, and then the growth expanded to Europe with nodes present in the most important internet exchange, such as Frankfurt, London, Paris, Prague, Amsterdam, Stockholm, etc. And then we started working in the Americas, both North and South America. Right now, we also have the fastest DNS protection coverage in the US and also in LATAM, in South America. We have a good coverage in Asia and in the Middle East, in Australia and in Africa. And now that's the global Anycast service. If you want to use a protected DNS, you need to be fast, reliable, and secure. So that's why the latency is so important for us. Some very important notes about latency. If you want to offer a very quality service, DNS resolution latency must be below 10 milliseconds. It's very important, otherwise a website surfing will slow down, and the user experience will be fairly terrible. And DNS in Flashstart is based on BGP, Border Gateway Protocol, and we can spread the same IP addresses all over the world. let me talk around the Flashstart dashboard. I have some slides in order to speed up everything because a live demo would take too much time. That's the very first page, and the Flashstart dashboard shows some numbers. Malware blocking, blocked request, not existing domain, total DNS request, and also the red categories are the blocked ones, and the green are the allowed category. The malware blocked is in gray, and the circle graphics shows the level, the weights of the different allowed blocked. Obviously, the interface is in English now. We have some Italian refuses. The report area can show trends, internet usages, etc., and it can also totally be exported through APIs, through SIM, and the integration with third-party system and platform is very easy to be done. The protection mask, the second one, consists in, first of all, three main drivers: threat protection, content filter, and application blocker. Threat protection can block malware threats. We have more than one threat intelligence. The very stable one, it has a very low false positive rates, but if you wanna increase, if you wanna enlarge the level of protection, you can also decide to activate the malware and threat communities. These are third-party threat intels provided by different partners and different probes running in several global contexts, but we need to accept a little bit more false positive. I'm talking about from 0.01 to 0.05 to intent. The content filter, the application blocker, is interesting because we can block, obviously based on the DNS resolution, different application types: dating, e-commerce, file sharing, games, crypto mining, VPNs. It's very important right now to block, for example, NordVPN. Otherwise, users will be able to circumnavigate filters, and the protection, in this case, will not be established. I am talking also around the importance of protecting mobile devices. DNS protection can be easily implemented into private LANs. So, for example, we can easily redirect DNS resolution on routers, on gateways, etc. But what will happen? What will happen when a certain user will go out of the network, or the user will start working remote or traveling? The user can be infected because the highest number of Wi-Fi networks, for example, hotels, airport, trains, cafe, and also home networks, are not secure, and the user can be infected, and as soon as that specific user will come back again to the protected to the internal network, he will be able to spread the infection to neighbor devices. That's why Flashstart has also introduced the full application set for the most important operating system, from Windows to Mac OS, iOS, Chromebook, which is very widespread in schools, and also Android. It's possible to bring to your own personal device, for example, my Android phone, the DNS protection with the same filtering profiles used inside the internal networks. In this way, the network admin can protect the whole company scenario, from the protected network to roaming users, having at the same time the same level of security policies and the same reporting. It's important. I am showing now, for the most technical people, a varied analysis tool. The name is DNS Perf. It's a freeware software. It can be downloaded. And we use frequently this tool in order to check the ability and the efficiency of our network. You need to have a very, very low lost query, 0%, and queries interrupt, 0.64%. It's an important tool, and if you're using your own DNS cache, you can download DNS Perf, and you can really send a massive simulated DDoS DNS attack to your platform. Benchmarking. When we talk around DNS, benchmarking, global benchmarking is very important. We are official member of DNS Perf. DNS Perf runs from more than 200 locations in the world. Every minute, some DNS query check. In this mask, you can see a normal DNS test history. The requests are coming from Brazil, Lithuania, United States, Netherlands, Asia, Japan, all over the world. And according to this, DNS Perf compared the most important top filtering DNS software, and Flashstart from January as the greatest DNS speed. So Flashstart right now has a global speed between 30 milliseconds and 40 milliseconds, and the investments continue in this way, and I believe you can find a very fast internet experience from all over the world. Now, to end my presentation, I want to talk about the resilience of DNS, and I want to introduce the federation concept. It's a very technical stuff. In the example, you can see the a part of our West Coast data center: Seattle, Bend, Silicon Valley, San Francisco, and Los Angeles. If something goes wrong, for example, if we will get a DDoS attack in Bend, in Oregon, the Bend will be federated with Seattle, Silicon Valley, and Los Angeles, and together the DNS will be resilient and then able to mitigate a larger DDoS attack. We learned from the past that DNS platform in the cloud is very sensible to DDoS attack. You can't change the IP address of your DNS service. Why? Because you are offering a DNS service, and networks have a configured to specific IP address. So since it's not possible to change quickly the IP address, we need to resist and to mitigate against a DDoS attack. BGP is very important because BGP can reroute DNS activity to the nearest data centers in terms of latency. For example, if we have an outage in Hong Kong, DNS resolution will be fully available from Seoul, Tokyo, Vietnam, Singapore, and Bangalore, and the latency, the increase of latency will be about 10, 15, 20 milliseconds, nothing. And the user will not be able to perceive, to experience any DNS traffic delay. Let me talk around just 1 minute, and then you'll be able to post your questions in the chat. The AI is critical. Flashstart makes an important usage of artificial intelligence because every day, more or less, 10,000 of new domains are put online, and we need to be very fast in terms of hours and sometimes of minutes to predict a new website. We need to quickly classify new domains and understand where a potential issue can be located. For example, every day, more or less 3,000 or 4,000 of DGA, domain generated algorithm are published in the world, and we need to put the update in the platform very quickly. So right now we can say that around the 98.5% of the domain running on a specific day are classified and predicted by Flestart. To end the presentation, some future developments. Passive DNS. We are investing a lot, and it's a public things that Flestart is spending a lot of money around passive DNS. What's passive DNS? It's a very simple technology. It consists in keeping a track between the FQDN, the domain, and the resolved IP address. For example, NewYorkTimes.com is being resolved with 68.7.5.10. Fine. And the IP address can be different in different global regions. And if we keep a track of passive DNS resolution, we can easily understand more domains infected by simply searching from the resolved IP address and the list of domains relying on that specific IP address. When we scale around very large numbers, more or less, Flestart serves more or less 16 billions of DNS requests per day. So with this high quantity of DNS requests, we can put artificial intelligence on passive DNS, and we can really sort of miracles. By the end of the year, you will, I believe, you'll be able to enjoy an empowerment in the zero-day malware defense protection. Fine. Question and answer, both for us and for Luca Deri. Luca, can you come back online? Raffaele, can you come back online again so we can see everyone? And if you have some questions, please be free to post everything in the chat. I'm asking to Luca if he can come back online now. And okay, here you are. If you have some questions. So let me start with a question by myself. Did you like the presentation? Do you have actually some DNS protection system or some deep packet inspection in your network? Do you find something useful for your business defense activity? Let's share some context in the chat. And meanwhile, if you want to add something, Luca.
Well, I think that what you have described makes a lot of sense. Security is not an on-off switch, but we need various components to be integrated. So therefore, I believe that domain names or IP address is protection, as I've said, makes a lot of sense. Particularly if you have a large distributed database such as Flestart that is continuously updated. I believe that DPI and DNS could be very well used to create a lightweight protection system for most of us, for businesses and for families, definitely.
Yeah. Okay. A question from Arcel. Does Flestart has something to offer to this? Can you please expand the question regarding this, just to better understand your question? Meanwhile, if anybody else want to post questions, the chat is now free, and I have just posted both websites Ntop is reachable at ntop.org, and Flashstart is reachable on flashstart.com. Can you repeat again the question, Arcel? Does Flashstart have something to offer to this now? Both one are commercial products for deep inspection. So Flashstart is a DNS protection system, is a DNS filtering platform. Deep inspection is in charge of Luca Deri with his company Ntop. Luca, can you expand maybe how to try and how to get in touch with you to try Ntop? Thank you.
Yes. So in essence, what we can envisage is something that we are discussing, is to combine DPI with Flashstart. So somehow put inside a gateway, a physical gateway or a virtual machine, let's say the ability of filtering traffic. Filtering can be transparent. So it means that you can insert in your networks a bridge, so you don't have to change any IP addressing plan. Or it can be an add-on component to an existing firewall, using those open source ones, such as based on OPN Sense, for instance, or others. So in essence, yes, the idea is that those two technologies can be combined. I hope I answered your question.
Thanks, Luca. And another question from Leon. Can we use our own DNS server, which is used as a sort of caching mechanism for the Flashstart DNS query? Definitely yes, because Flashstart DNS is in the cloud. And if you have a local DNS cache, for example, running with bind, unbound, power DNS, DNS dist, no problem, because you can install you can set up the Flashstart Cloud DNS service as a simple DNS forwarding system. So it's possible. We have several partners using their own caches. Most of the time they build secure caches by themselves. It's possible. And yes, you can absolutely set up both Flashstart DNS as a normal DNS resolvers. You can also take benefit of multiple DNS couples. So for example, you can have a DNS filtering system for malware only, a DNS filtering system for malware and both bad content. And you can decide to enroute, to forward a different DNS client to different DNS cloud system. Let me remember that we have a partner. It's located in Denver in the United States, and they are very, very, very focused in building very high-level DNS caches. The name is Secure 64, Secure 64, and I'm very proud of mention this great partner, which has an incredible ability to build very, very strong and robust DNS caches. Another question from Ethan. There are some websites that do not allow decryption of HTTPS. Good question. Is DPI still effective on that scenario? Yeah. This question is for you.
Let me answer the question with an example. Okay. Okay. This is a live example. Okay. So I'm running today on a Mac. Okay. So there is a communication based on TLS. As you can see, it's encrypted. Okay. And at the bottom of the screen here, okay, our tool reports also the content. As you can see, it's all obfuscated. There is nothing you can read, except a few words. You see, this and this, okay? Basically, I have not said, okay, if you want, I can clarify that. I have not said that we are going to decrypt the traffic. TLS and other type of traffic, so DPI, is not going to be decrypted by DPI. It stays encrypted, okay, simply because we are also unable to do that. It's not possible. But as you can see, we extract the domain name we are talking to, okay, and we extract, for instance, the protocols or other features of the communication. And this is perfectly enough for me, because with this one, I can identify, for instance, this is an iCloud communication. So if you don't want me to talk with iCloud, we can stop it, and that's it. So therefore, DPI works with encrypted traffic. Okay, encryption is not a problem. Actually, it's an opportunity, because with encryption we can have, for instance, fingerprints, specific fingerprints for detecting the traffic, especially for malware. That is very relevant. So just to answer your question, yes, it's not a problem. So we are good even with encrypted traffic that cannot be decrypted.
Okay, just to okay, understood. Okay, great, great answer, Raffaele. Do you want to add
Morning,
anything
everyone.
else?
Sorry,
Meanwhile,
but I had a connection problem. It's strange to say
here you are.
in this moment, but it's okay. I'm Raffaele Borgese, as Francesco told before. I'm CEO of IES Italia. IES Italia is an incubator, and have managed different startup and company. One of that is focused on giving connectivity to the cruise and ferry company all over the world.